In this video, I'm going to explain a little bit how to get on to the Turing.Tusculum.edu server, how to get around a little bit, and how to create and compile a C++ program. So the first thing you have to do, you have to think about which kind of computer system that you're on. If you're on a Macintosh, you simply go to the terminal window and you type in SSH space, your username, the ampersand, Turing.Tusculum.edu. That'll take you right in. The same thing will work if you're on any version of Linux or Unix. Just go to a command prompt and type in the same thing. Windows does not natively support SSH as a protocol, and that's all it is. It's a secure way to connect to a remote server, so you have to download a special program. So in order to do that, if you go to the web, you can go to Putty, Putty.org. So Putty's the name of the program we're going to use. Okay, that should pop up in a second. And then you can download Putty here as the first link that you want to take. Okay, so you want to definitely take that one. And then you go down and find the Windows version that you want. Okay, so the Windows, any of the first version here is perfectly okay. You can click on either of these two guys, the FTP or the exe file, and that will download it. So once you get it downloaded, it will run. It doesn't require any administrative rights. You can install this in a lab, pretty much any Windows computer. So once it's installed and you pop it up, it's going to look like this. Okay, so you have the Putty configuration. So in these menu boxes here, you type in Turing.Tusculum.edu. That's Turing. You leave the port at 22. That's all you need. You click OK. It's going to take you in. So you log in as the username, which is the first part of your Tusculum email, and the password, which initially is set to QWE123. You're going to want to change that right away, but that's the basic idea. Okay, so let me make this full screen here, make it a little more interactive, a little easier to read. Okay, so to change your password, if it is your first time in, you can type in PASSWD. It will then ask you for the old password, which is QWE123, and then you can type in a new password. Okay, it tries to hack your password immediately, so it may have to try a couple of times in order to find a password that's going to be useful. Okay, that will actually work. Once you've done that, you may want to write it down somewhere, but nowhere anybody else can get to it. Okay, so Turing.Tusculum.edu is a computer, very much like the one you're on. It's a server that's located in Nicewater. Okay, so we're going to connect remotely to that. That way, I have some control over what software is there, and when you turn in your homework, I'll be able to see it automatically and grade it. Excuse me, it's allergy season. So all in all, that's all good things. Okay, so let's talk about what you can do once you get on here. Okay, the first command that's important, and there are two versions of this. There's the ls command, which will list all of the files, and depending on the computer that you're coming in from, you should see some differences here in that files that are regular files will be in white. You can see on the screen there. Files that are directories are in blue, and files that are executable are in green. So this color coding, at least that's what it is on mine, maybe different on yours, kind of lets you visually know what's going on. And the ls is a list short. There's an ll command as well that's going to list more information. When you guys first get into your account, you won't have any of this stuff. You won't have any files at all to speak of, so don't worry about that. But it does list where you're at. Okay. As far as the directory you're in, that's also very important. We're going to turn homework into very specific locations. So if you do a pwd command for the present working directory, it's going to show you that you're in the /home/your username. That's where we start off at. Okay. So from here, you're going to want to create a directory for the CISC 110 class, and you'll probably create directories for other classes you take in computer science. So we do that with the mkdir command, a space, and then CISC 110. Note that case is important in Unix, so CISC with all lowercase letters is different than if any of those were uppercase letters or all of them. Okay, so case does matter. Okay, I'm not going to do that because I already have one. Okay, if you look on the screen here, you will see that I do have this CISC 110 directory. And note that I'm using my mouse, but the mouse doesn't do you any good when you're on the server. Okay, except to highlight things for me to show you what you're doing. Okay, so we can do a CD here as well and go into our CI. Now, one thing you'll note that's nice about the the Linux system we're on, it has command completion. When I do a CI and that's it and stop, I can press the tab key and it fills in what it can. Okay, so if it's unique enough, it should fill in everything, which is nice. Okay, now if I do a pwd, you'll see that I'm in the home/username/CISC110 directory. Okay, I do an LL here, and you see that I do have some information, some files that I've created in class, and starting on the chapter 1 homework. Okay, so each chapter that we do in the class, you'll create a new directory with the mkdir with a capital C chapter, and then whichever name it is. Okay, so we'll just continue to do that as we go along. When I go to check the homework, that's where I'm going to look to see where things are. Okay, which should make some sense. Okay, so now that we're in the proper directory, again, we can do pwd here to do some just in-class work or whatever. We can go ahead and think about creating our first C++ file. Again, this video is not going to talk much about the syntax of C++. This is a how to get started kind of a video. Okay, so we're going to go ahead and create the infamous Hello World program. Okay, so I'm going to do it. The editor we use is called Emacs, and I handed out in class, or at least I should have, an Emacs quick reference card. Emacs does tons of things. We're doing it at a fairly low level. So we're going to call this hello world.c. You will see C files, C++ files, sometimes listed as little c, sometimes capital letter C, sometimes CC or CCP. It doesn't matter as long as you're consistent, but for this class, let's use C so I'll know what you're doing. Okay, but if you see those others, you'll at least kind of have an idea what that is. Okay, Emacs is our editor. It's kind of like Word, but it doesn't create formatted documents. It creates plain text files. Okay, so we're now in. One thing you will find about Linux, it's very sparse. If you do a command and it works, it doesn't tell you anything. So right now it looks like a blank screen, but you actually are in Emacs. So you can now do what we need to do. Okay, so our Hello World program, like all of our program, starts with an include. We're going to include the Iostream. Iostream is a library that's built into the C++ system. The G++ is a version of that we're using that allows you to do input and output to the screen. Okay, and for convenience, we're going to do a using namespace standard. Okay, the first line, because it starts with the octothorpe, is going to be what's called a processor directive. It's not C language. It's something that the compiler knows to do something else with. Okay, starting in the second line for us in this program, we are in C++, so most lines need a semicolon after them. Okay. Then the next thing that's part of every program we're going to do is we're going to create a function called main. Every C++ program has to have a main function. Okay, it's the int comes first, and we'll talk about this more in class. But that's the return type of the function. The main function should return an integer, which we'll do that in a minute with the return statement. Okay, the body of the function is going to be enclosed in curly braces, and you'll notice that one nice feature about Emacs, when I hit the closing curly bracket, it moves the cursor back up to the one that it matched. If I do that again, it doesn't match anybody. Okay, and it tells you, in fact, at the bottom, no matching parentheses found. Okay, down here it tells you that. Okay, so it tries to be your friend whenever possible. Okay, so the only command that we want to do here is one called cout. Cout stands for console out. Okay, we're then going to use two less than signs. Now, when we get to input, user input, we're going to use the other way, the two greater than signs. But in this case, what the string that we're sending is going in the direction of the console. So that's how you can remember which way the arrows go. Okay. The message we want to print out, we're going to type it in side of quotes. Okay. In double quotes. That means it's a string. It's a literal string. Okay. And then, so we want to have it not end on part of a line. We want to do a new line character. We're going to do the endl. So endl is nothing more than, in actuality, what we could have done also is a \n. Okay, and we'll do that sometimes in our code as well. Okay, but that has to be inside of quotes. Okay, but the endl does not. Notice that when I did the semicolon, it automatically indented the code for me, and that's really an excellent idea. Okay, so the book talks about it's important in the style that we add comments when necessary. Okay, most programs would have a comment section at the very top, very first thing, gives the program name, your name, what it's supposed to do, things like that, any formulas that you're using, all of that. Okay. But in this case, I'm not going to do that because it's relatively straightforward. Okay. So when you want to get out of your code, Control X and then Control C. Okay. On your little card, the big C stands for control. I think that the big M is usually the Alt key, sometimes the Windows key, but one of those two. Okay. At the bottom, it's hard to read a little bit, but it's asking me, do you want to save the file? And the basic options we care about are yes and no. So I hit a Y for yes, the file's saved. Okay. So now when you do an LL or an LS, you'll see that the hello world.c program is now there. Okay, I called this hello in class, and that was already there as well. Okay, the hello world.c is there. It gives us some other information here that could be useful to you, depending on what you're trying to do. Okay, it's going to give you, first off, when the program was created. So you know that today it is October 12th. Okay, and for some reason it has the time of being off. We're off by an hour. It must not have adjusted for daylight savings time. It's actually 12 o'clock, not 11 o'clock. Okay, so I know that it was today. So if you have multiple versions of programs with similar names, this will tell you which one was created most recently. It also tells you the size of the file. Notice that some of these are very big, some of them are very little. And then it also has the owner of the file, which is my username. And on our system in particular, we don't really implement groups, so everybody is in the same group as their username. You're in a group of one, in essence. Okay. Then over here on the far left, it shows the permissions. So the permissions can be read, write, and execute. The very first digits, whether or not it's a file or a directory, you see that I have a directory called Chapter 1 that has a D there. Okay. And the first set of permissions are for me. Okay. So I have read access to this. I can see it. I have write access. I can make changes to it. I do not have execute because you cannot execute C files directly. Okay. The group, which is the same as me, has the same permissions. Now the world, assuming they could get into my directory, which they can't, but if they could, can read the file but cannot make any changes to it. Okay. All this happens by default at this point, and we should be okay with it. Shouldn't be much else. Okay. You will note that where I'd compiled the program before, the hello program, there's a star at the end. It's in green. And also you see that it has read, write, execute for me and for my group, which is just me, and for everybody as well. And also it does that automatically. Okay. So the next thing we have to do, and we talked about this in class, we have to compile our program. We compile it into object code. We are then going to link it with other system libraries to create an executable. Now, in our system, we do that all in one step. Okay, so we're not going to have to do that separately. So if you do this one line, it's going to do all the linking, all the compiling, all the everything, and spit out an executable. Okay, we're going to use the G++ command for this. Okay, to compile to an executable. We're then going to use the -wall with a capital W. And what that does for us, since we're beginners, it's going to turn on all possible warnings. So if you have any errors, it's going to give you the most information about it, which you want to know about. Okay. We're then going to type in the name of our program, hello world.c. Okay. We're then going to do a -O. That's a small o. The -O, and it's not a 0, it's a letter O, is going to create the executable file for us. You can give it whatever name you want, but by convention, we're going to call it hello world without the .c. Okay. If you put the .c in both places, it will overwrite your original source code. You won't be able to make changes. So try not to make that error. Okay. So it's done. And if it returns with no information, again, it's Linux, that means life's good. Okay. So we think that things should be fine. To actually run the program, well, first let's see that it's there. And yes, that you see now that the hello world is now in green. It has the little ampersand at the end. You'll also note that the file size is much bigger. We've gone from 90 bytes to 7,830 bytes. Okay, that's all the system libraries that get built in, and we're converting that into machine language code. Okay, so to run this, we have to do a // We do that to point out that we want to run something in our current directory. It doesn't do that by default. That's a Linux thing as well. So we type in hello world, and again, I can use a tab completion after I get the hello W. When we do that, it runs and prints hello world on the screen. Okay, so that's the basics of creating a file. And you'll do this enough, it will eventually become second nature. The other thing I want to point out is that if you're in your program and you find that instead of hitting a Control X, you hit a Control Z. everything goes away. Your file was suspended, the job was suspended, it's stuck. Okay, so there's no real obvious way to fix that. The way you fix it is hit the FG command, which stands for foreground, and it's going to bring the file back to where you were. Okay. You will also note on your file listing sometimes, you will see file names with, here's an example of one, a little tilde at the end. The one with the tilde at the end is going to be a backup file that Emacs will make every now and again. Okay? And if you see a file name with 2 octothorpes around it, it means it's got locked somehow, and you may have to do some fancy footwork to get to it. But you still should be able to. Okay? So that's about it as far as things that you can do. You can do the W command if you want to see if someone's online or not, if you want to send them an email, okay, or whatever, okay. And then when you're all done, you want to exit. And to exit, you type in EXIT, and that's it. Okay. So that's been a brief introduction to the Turing Server and how to get along basically in Linux. If you have any other questions, make sure that you let me know in class or email or call or something.